Ever wondered if those mammoth meatballs you heard about were the real deal? Last year, an intriguing claim from the Australian startup VAO took the world by storm. They professed to have accomplished the impossible, producing meatballs using the DNA of the long-extinct woolly mammoth. Quite the proposition, wouldn't you say? It all began during a brainstorming session for a video on cultured meat, an exciting and sustainable solution to our growing demand for meat products. VAO, always pushing the envelope, decided to take it a step further and venture into the world of prehistoric cuisine. Now, let's talk about the process. The initial understanding was that VAO used the complete DNA of a mammoth to create these meatballs. But as we dug deeper, a different picture began to emerge. Turns out it wasn't the full mammoth DNA at all. Instead, they extracted a specific gene that produces myoglobin, a crucial protein that transports oxygen in muscles, giving meat its rich, juicy texture. This gene was then inserted into sheep cells. Yes, you heard it right, sheep cells, not elephant cells, as one might presume, given the mammoth's close relation to the elephant. But here's the twist, they didn't stop at just the mammoth gene. To complete the DNA, a part of the elephant gene was also added to the mix. A mammoth sheep-elephant hybrid, if you will. This revelation raised more questions than it answered. It led us to wonder if these meatballs were truly made from mammoth meat, or were they just sheep meatballs seasoned with a dash of mammoth and elephant myoglobin. And so, our investigation continued. We delved into genetic sequences, explored the relationship between myoglobin and meat taste, and even stumbled upon an article that had already brought these questions to light. But the more we delved into it, the murkier it got. Stay tuned as we unravel the mystery of the mammoth meatballs in our next segment. With suspicions aroused, we embarked on a research journey into the world of genetic sequences. Picture this, a vast digital library housing the genetic makeup of countless species, ready for the curious explorer. This is where our quest took us. Our investigation first led us to the genetic sequences available in international databases. Think of these databases like a genetic library. They house the genetic information of countless species, from the tiniest microorganisms to the largest mammals. It's a treasure trove of information for anyone willing to delve into its depths. We were particularly interested in the myoglobin gene sequence of mammoths. Myoglobin, you might ask? It's a protein that transports oxygen in muscles. The Australian startup claimed they used this gene from the mammoth DNA to produce their meatballs. As we delved deeper into the digital genetic library, we made a surprising discovery. The mammoth myoglobin gene sequence was nearly identical to that of African and Asian elephants. Nearly identical, mind you. This was a curveball. If the mammoth and elephant myoglobin genes were so similar, then how could the company claim they were producing mammoth meatballs? Could the meatballs be made from something else entirely? We started to piece together a theory. Perhaps the meatballs were not made from mammoth meat at all. Instead, could they be made from sheep meat, seasoned with elephant myoglobin? This would certainly be an easier and more cost-effective method of production. But then again, this was just a theory. We needed more evidence to back up our suspicions. We had to delve deeper into the world of genetics and understand more about the role of myoglobin in meat taste. Could it be that the mammoth meatballs were nothing more than sheep meat seasoned with elephant myoglobin? With this question in mind, we set out on the next leg of our investigation. Little did we know we were not the first to tread this path. We then asked ourselves, could myoglobin be the magic ingredient that gave the meatballs their unique taste? In our quest to unravel the mammoth meatball mystery, we dove into the world of myoglobin, a protein that plays a crucial role in transporting oxygen within muscle cells. You might be familiar with myoglobin's cousin, hemoglobin, which performs a similar task in our blood. Now, if myoglobin could give a mammoth its mammothness, could it also be the secret behind the unique flavor of these meatballs? To answer this, we turned to scientific literature and found a wealth of information. We learned that myoglobin does indeed contribute to the taste of meat, but not in the way you might think. You see, myoglobin itself doesn't have a taste. Instead, it affects the color of the meat, which in turn influences our perception of its flavor. A steak's reddish hue, for instance, is due to its high myoglobin content. But here's the kicker. Our research revealed that the myoglobin proteins might not be as decisive in determining meat taste as we initially thought. What truly gives meat its flavor is a complex interplay of factors, including the animal's diet, its age, and how the meat is cooked. In fact, the contribution of myoglobin to meat flavor is so minimal that it's virtually undetectable. So, if myoglobin doesn't significantly affect the flavor, what could be the magic ingredient in these mammoth meatballs? Could it be something else in the mammoth's genetic makeup, or perhaps a secret ingredient added during the cooking process? Or could it be that the meatballs don't contain mammoth meat at all, but rather sheep meat seasoned with elephant myoglobin? The plot thickens. It seems we're far from the truth. Just when we thought we were onto something big, we stumbled upon a shocking revelation. As we dug deeper into our research, we unearthed an article that made our hearts sink. The author? None other than Love Dalen, a professor of evolutionary biology who was already known for his extensive work in the field. Now, Dalen's name may ring a bell to some of you. He's a frontrunner in the study of prehistoric DNA, and his work is nothing short of groundbreaking. But what caught our attention was not his accolades or his lengthy list of publications. It was a particular piece of research that felt all too familiar. Dalen had already discovered and extensively discussed the similarity between the genetic sequences of elephants and mammoths. Yes, you heard that right. The very same discovery we thought we were on the brink of making had already been made. It was like opening a present only to find it empty. It was a humbling moment, to say the least. We realized that we were not pioneers on a new frontier, but rather followers in the footsteps of giants. Our groundbreaking discovery was not groundbreaking at all. It was a stark reminder that in the vast realm of scientific exploration, we're often not the first to tread new ground, but you know what? That's okay. In fact, it's more than okay. It's a testament to the timelessness of scientific inquiry, a nod to the interconnectedness of our collective knowledge. We are all part of the scientific community, building upon the work of those who came before us, and paving the way for those who will come after. So, where does this leave us? Did we crack the case of the mammoth meatball mystery? Or are we back to square one, sifting through the remnants of a theory that's already been explored? It seems we were late to the party, but does this mean we're back to square one? So what does this all mean for the mammoth meatballs and for us? In the grand scheme of things, our investigation has uncovered that the mammoth meatballs were perhaps not as mammoth as they were made out to be. The Australian startup VAO might have been pulling the wool over our eyes, with sheep cells playing a much bigger role in this culinary creation than mammoth genes. It appears that the mammoth's claim to fame, the myoglobin protein, is not so unique after all. With the genetic sequence of this protein being nearly identical in African and Asian elephants, it's more likely that we're tasting a concoction of sheep and elephant genes rather than the prehistoric delicacy we were promised. But this story is not just about debunking a mammoth myth, it's about the pursuit of truth, the importance of quality, and the commitment to originality. It's about not just accepting what we're told, but digging deeper, asking questions and seeking answers. I want to express my gratitude to all of you who've joined me on this journey. Your support fuels my curiosity and drives me to continue this quest for understanding. But we're not stopping here. The path to knowledge is never ending, and there are countless more mysteries to unravel. We'll continue to explore the fascinating world around us, delve into the intricacies of science, and share our findings with you. We're currently working on some exciting new investigations, including a deep dive into the world of quantum physics, a journey into the heart of our galaxy, and an exploration of the intricate ecosystems of our oceans. I promise to continue seeking out unique, quality content, pushing boundaries and challenging assumptions. Because that's what we do here. We don't just accept the world as it is. We question, we explore, and we strive to understand. The mammoth meatballs may not be what they seem, but our quest for truth and quality never ends. Stay tuned for more exciting investigations.